Hello everyone, I'm Mike. This video is about the way we use Arduinos and other electronic bits to bring digital control to our DC railway layout. I think it introduces a bit of realism to some of the old 60s stuff. Let's see what you think. It's likely that you know more than me about some of this, in which case please leave comments in the comments section. We're all learning all the time. And if it's a bit too simple, then sorry about that. I'm afraid the video goes on a bit, but then so do I. Okay, blah blah blah. Analog, wavy lines. Digital, square lines. It's either on or off. So looking at that a bit more context, with analog, we're talking lots of technical stuff here, brushes, commutators, armatures, etc. I hope you know what we're talking about there. But with analog, basically, you get current supplied to it, increasing voltage, and when there's enough to turn the motor around, the motor starts to turn. I'm using one of my travelling layouts here just to demonstrate this on. Okay, I made this bit up. Basically it's how I think it works, and I've had this impression that digital motors can work much slower and much finer than analog ones, and well, judge for yourself. Here is a box, a signal box. And just to prove that it goes backwards as well, this is just my impression really, that when you start trains off, once the momentum starts, they tend to increase in speed and you have to turn them down, whereas with the digital controls it does seem to stay at a more constant speed, but maybe I'm wrong. I've realised that I've already mentioned PWM without explaining what it stands for. The only thing I need to add is that I'm only trying this on old XO3, XO4 motors, the equivalent. I'm told that it may not work very well with the more modern CAN motors and the Chinese stuff. So, up to you if you want to risk it. Now moving up to the loft layout, where I've added in this sort of jumble of wiring on a bit of wood to the right of the existing controls to try and demonstrate things further. So here's the Trine controller operating in the conventional way. So the Arduino controllers come in a range of models. This is actually an Arduino Uno, but they all look very similar and they all do very similar things. And as mentioned before, we're wiring this up to provide one direction power. If you want to reverse as well, you have to add a suitable switch to reverse the polarity. We'll talk about programming the Arduino in a minute, but in the meantime, here's a list of the other components you'll need. Solderless breadboards or breakout boards are a good way of mounting most electronic components and providing quick wiring between them, no soldering involved. I expect you know resistors are marked up with coloured bands which tell you what rating they are, or you can use a meter. This picture is borrowed from the DroneBot workshop channel. I'm using a slightly different MOSFET and I've upgraded mine to 12 volts. I've shown you the various stages here of connecting it all together. I'm sure if you want to follow it exactly, you can rewind and pause the video at appropriate points. I would just add though that the resistor between the digital wire and the leg of the MOSFET is very important. So we use pin 9, which is a digital pin in the Arduino, to send the message out to the MOSFET. The potentiometer is basically the speed controller, and the way it works is that it's a great big long wound wire, and the resistance from one end to the other is about 10,000 ohms, and you connect one end to live, one end to ground, and then the wiper, when you turn the central spindle, touches the wire at various different points from one end to the other, and you get a different measurement coming back, and then that goes off through the centre wire to the analog connection on the Arduino. Hooray! Back to something we understand. The power track at the bottom of the breadboard is going to be used to connect up and provide power to the track. So that's what the blue and black wires are for. You might spot in later photos I had to reverse them. So one of the issues you get with these systems is that all the ground or negative ends of the power supplies need to be bonded together. So I'm bringing the power feed in from a battery to the top row and then just jumping it across to the bottom row to feed the live straight back out again. So if you're lucky, that's all going to work first time. And if not, that's fun finding out why. The extra line on the bottom just tells us that when you turn a motor off, the fields can produce a current which is sent back up the wire, and we don't want that damaging the electronics. So that's what the diode was for. The diode detects the current and passes it through to ground to protect the circuitry. Okay, the scary stuff then, programming the computer. It's quite simple. You just say how you want things to work, then it runs through a little routine that sets everything up the way you want it, and then it goes into a loop phase where it just repeats the same old instructions over and over again. Here's the programming tool, and here's my basic list of instructions. It's very, very simple, and it will just repeat that every time the machine's powered up. Why bother, I hear you cry? Well, initially it was a bit of fun trying it out, but there's got a serious point to this because we can add more stuff once we've got a programmable power source, and we can get it to do things like starting and stopping automatically, or at stations, or not stopping. Possibilities are endless. So that's pretty much it now. I've got a few bits of footage I've taken both on our test layout and on the main layout upstairs, just to show you work so far. There's more to come. So first of all, we'll use the potentiometer to just start the train, stop it, start it again. Typically it's a dead spot. And this time I've programmed it to start and stop a few times, and we're just going to power it on and see what happens. Finally it's back up to the loft to see the Pullman running with PWM. That's it for this one. Thanks for watching. Bye.